Hello. Today we will survey our solar system. The solar system is occupied by a diversity of objects, but show an underlying order in the dynamics of their movement. Um, the planets in our solar system are formed two main families. A solid rock in a planet that we refer to as terrestrial because Earth-like, and a gaseous liquid outer planets we call Juvenian because Jupiter-like. From these observations, astronomer has deduced that the solar system formed some 4.5 billion years ago out of a collapse of a huge cloud of gas and dust. Now, the sun is the center of our solar system. It's not too long ago it was believed that the sun was not the center and the earth was the center. A sun center solar system we refer to as heliocentric, and a earth center is geocentric. Um, it was the work of Copernicus that showed that the sun was actually the center of the solar system, and Galileo confirmed showed that the sun was the center of the solar system, and Galileo confirmed by experiment that this was indeed true, that the sun was the center of the solar system. um, the sun is really a star, a ball of incandescent gas whose output is generated by nuclear reaction in its core. Later on, we will study this in more greater details. The sun is composed mainly of hydrogen. It is 71% hydrogen and 27% helium. It also contains traces of nearly all other chemical elements. The sun is really massive. It is 700 times the mass of the rest of the solar system combined. Now, by Newton gravitational law, this will show why the sun drives our solar system. So everything in our solar system orbit around our sun. Its large mass provide the gravitational force to hold the solar system, to hold all the solar system bodies in their orbit patterns around the sun. Now we see that most of from this slide we see that most of the planet orbit in a plane around the sun, except for Pluto, which has an orbit that tilts about 17 degrees, and these orbits are almost circular. They're not perfectly circular, as Kepler has shown that the planet moves in an elliptical orbit. All of the planets travel counterclockwise around the sun, and that can be seen. From high above the Earth's North Pole. Six planets rotate counterclockwise. Venus rotate clockwise, and Uranus and Pluto appears to rotate on their side. It is believed that this might be due to, at least for Uranus, it might have been due to some asteroid collision that knocked it over on its side. Now we can see that the the diameter of the inner planet is about 3 AU, whereas um, on the it's about 80 AU from of the outer planets. The inner planet composed of Mercury, Venus, Earth, and Mars. These are mainly small, rocky, mainly silicon and oxygen are the makeup composition. Bodies with relatively thin or no atmosphere. Um, we also call these planets terrestrial, meaning Earth-like. And to understand planet, we tend to study. Most of our composition or understanding of planet is made up from our understanding of Earth, to understand the terrestrial planet, and we we extensively study Jupiter in order to have even more understanding on the other gas giants. The outer planet are Jupiter, Saturn, Uranus, and Neptune, and it's mainly made up of gaseous and liquid ice. And again, as mentioned, we refer to this as Juvenian planets. Juvenian planets are much larger than terrestrial planets and do not have a well-defined surface. The next type of planet is what we call dwarf planet. It was in 2006 that Pluto was downgraded from a planet to a dwarf planet. By dwarf planet, we mean that not massive, not massive enough to pull themselves into circle shape. Orbits have not been swept clear of debris. So these are mainly two criteria used to classify planets as dwarfs. The number, many of these planets in our solar system has other objects that orbit them, and we call these these objects satellites. In some cases, we call it moon. So, like for instance, Earth has one satellite, which we refer to as the moon. Mars has two. Neptune has 13, with Jupiter has a whopping 62. Mercury and Venus are moonless. But moons moons are generally formed due to these planets capturing an object, even though there are various theory and how this happened. At least there are at least three theory on why about the Earth's moon, which we will discuss later. The next set of things that is contained in a solar system are asteroids and comet. Composition and size. Asteroids are rocky or metallic bodies ranging from size of a few thousand kilometers across to 1/10 of the diameter of the Earth. So one of the issue that trouble us sometimes is an asteroid colliding with the Earth. Not too recently, an asteroid passed very close to the Earth, and we know that if an asteroid of 1/10 of the diameter of the Earth should hit it, it would be very catastrophic. Then we have comets, and comets are very spectacular when viewed in the night sky. Comets are icy body about 10 kilometer or less across that can go very long tail of gas and dust um, as they near the sun and vaporize by its heat. So again, that the tail really comes from the evaporation of or the melting of the ice as it approached the sun, and you get a spewing of ice and dust in like a tailwind. Um, However, the comet spend most of its time away from the sun. So in at this time, it's just an ice ball. The comets are mainly occur in basically the out cloud, and asteroid are located into what we call the asteroid belt between Jupiter and between Mars and Jupiter, indicating that these asteroids are failed building blocks of a planet. And when one looks at Boyd theory, Boyd shows exactly where this asteroid belt is. There should have been a planet. Some comet may come also from a disk-like swarm of ice object that lies beyond Neptune, extended perhaps 1,000 AU in a region called the Kuiper Belt. But most comets orbit far beyond Pluto in the out cloud, a spherical shell extending from 40,000 to 100,000 AU from the Sun. Um, Finally, the other thing that we want to look at is measuring composition. Since the inner and outer planet are different dramatically in composition, it is important to understand how the composition are determined. A planet reflection spectrum can reveal the planet atmosphere content and the nature of the surface rock. And reflection spectrum are very important because, as you know, the only place that man has traveled is out to the moon. Beyond that, the information we gathered are mostly from reflection spectrum. That's why in chapter 4 we look at light and behavior of light to understand how we could analyze the light that we see coming from space. Seismic activity has only been measured on Earth. So again, we use Earth to understand the mix-up of other planets. And from what we understand how to measure the density of Earth, then we can transcribe that to measure other densities. So planet average density is determined by dividing the planet mass by its volume, and the mass is determined from Kepler model, from Kepler modified law. As you know, Kepler law shows that the period is proportional to the square of the period is proportional to r cube, and the volume is derived from the planet radius, from the planet's radius. So once the average density is known, the following factors are taken into account to determine the planet's interior composition and structure: the density of abundant candidate material, variation of the density as a result of compression due to gravity, and surface composition determined from reflection spectrum, material separation by the density differentiation, and using mathematical analysis of equator bulging. Um, this will be all we have time for today. Tomorrow we will start by looking more at the composition of these objects in more detail. Thank you for your attention.